Okay, so to start off with a very brief background, in 2010, the Eskom board took a decision to extend the life of Koeberg. Koeberg was built in the 70s. It came online in the 1980s, 1984, the first unit, and it has a 40-year operating lifetime, which comes to an end in 2024, in July. And in 2010, the Eskom board took the decision to extend its life, and they did a business case and so on. And there's records of that, one can see it quite clearly. And the price or the estimated cost of that process was 20 billion Rand in 2010. Now, for a long time, Eskom kept claiming that the price was still 20 billion Rand. And this really made no sense at all. There are two options there. Either they were lying, it was wrong, or the scope of the work had somehow dramatically been decreased in order to keep the cost at the same level as it was in 2010. So what we're going to do today is I'm going to talk very briefly about that, and then a set of background, and then talk about that cost. And then Clyde, who's the smart one in the room, is going to talk about how the outages of Koeberg in the attempts to do this refurbishment have impacted the economy and the country. So let's just first look at a broad overview. When you're looking at extending the life of Koeberg, there are three different categories of cost. The first is an actual engineering cost, the actual contract work to work at Koeberg. The second category of cost is the indirect costs to Eskom. For example, there's an Ankerlicht transmission line project, and that is purely aimed at providing a backup power source to the Koeberg plant. So the cost of that really should be allocated to the Koeberg life extension, but I don't believe that is how it's done. There are other indirect costs to Eskom. For example, they've lost their chief nuclear officer and they have to recruit a new one. And the only reason they need a nuclear officer, of course, is because of Koeberg. So that's the second category. And the third category are externalized costs. And those are costs to the country. And we're going to be looking at each of those in turn. So the first step is going to be very, very simple. If you take a calculator, and I'm going to share my screen now, and you should see this calculator sitting here, and that's 20 billion Rand. In 2010, the Rand was 7.50 Rand to the dollar. So if we take that figure, we come to about $2.67 billion is what it would have cost in 2010 figures. Now, obviously, there's been inflation, but quite high inflation in South Africa, quite low in the US. It wouldn't be fair to use the South African inflation figures because we're talking in dollars. So if we take that 2.67 and we put it into an inflation calculator for the US, and that's easy to find online, then we find that that figure comes to about 3.65. Another one gave me 3.67. So in 2010, it was 2.67 billion US dollars. And with inflation, we would expect in August 22 that that would be about 3.65 billion US dollars. So if we go over to our calculator again, and we come with 3.65, and we look at the exchange rate today, it's about 18 Rand to the dollar. And we can see that that brings that figure to 65 billion. So what was 20 billion in 2010 rands is if we're buying something from overseas, like from a US company or a European company, then it's going to be approximately 65 billion Rand in today's cost. So Eskom have been very cagey about what the actual cost of the Koeberg refurbishment will be. They even avoided a parliamentary question the other day by terminating the session. And if one looks at this very simple calculation, it's maybe an indication of why they're not that keen for those figures to come out. It'll be very simple for Eskom to refute this. Just produce the business case, produce the figures. Let's have a look at what's actually being done. But that so far has not been forthcoming. So in addition to that, I think you've all seen the slide that went out with the email. If you need it, I can send it to you. This was on Tuesday. Eskom made a presentation to Parliament, and for the first time, they actually admitted the 20 billion was wrong. And it was really funny in a sad sort of way how they phrased that. They said that in today's value, it would be significantly different. They couldn't even bring themselves to say it will be more. It'll just be significantly different. And from the calculation I've just done, I think we can see how significantly different that is likely to be. But in the same presentation, underlined there in red, they also said that there's been a 1.5 billion rand interest penalty. And you can see how that happened. They purchased these steam generators a long time ago, and there's been delay after delay. So they've been sitting there accumulating interest. So that needs to be added to our estimated cost of 65.7 billion. And if we then look at the penalty that was charged by Framatome to Eskom for the bungled January-February attempt at replacing the steam generators, I'm sure you've all seen that in the press, the building wasn't ready and so on. And that was reported in the Daily Maverick as a 1.1 billion penalty. So that needs to be added to that as well. So if you take those figures and you add it up, go back to my presentation here, what is the total? So we can add that up and it comes to what it comes to. You can see it there. Now, a few other factors is that Eskom projects, particularly the large-scale projects, are rarely done on budget. And if we look at something like Medupi and the other big projects, they end up costing about 2 or 3 times what the original estimate costs. And if we take a very conservative, bit less than double, that 65 billion is going to work out to something like 130 billion rand. So I think that is bringing to an end what I would like to say, except for if you do work that out and you work out the cost of capital for Eskom, obviously is very high because of the high debt that it's in, you'll find out that if they were to refurbish Koeberg, it will be far and away the most expensive electricity ever generated in South Africa. So I think with that, I'd like to hand over to Clyde, and Clyde's going to be looking quite specifically at 2 things. One is from the 8-month outage we've had this year for Unit 2, which, remember, they didn't manage to replace the steam generators, so it wasn't necessary. All that was necessary was a 5-week outage for refueling. Clyde will tell you the cost to the economy of that and also the cost to Eskom, and then some speculation about if they go ahead with the other 2 long-term outages as planned, what the total cost will be to the economy. Thanks, Clyde.
I don't know if you want to, that's absolutely fine. Yeah. So I just want to kick off by saying that when I first started speaking to Peter some time ago, I, like many others, said, oh, but surely a life extension of Koeberg makes sense. You know, it's the cheapest electricity provider on the Eskom grid. And Peter kept saying, yeah, but what about the safety elements? And so I said to Peter, well, it's still, at least it works economically. And he said, well, have a look at it, Clyde. Let's see if it does. And I said, okay. So I then modeled what I thought we might have as additional load shedding, an additional load, an additional diesel usage for the planned 6-month shutdown in 2022. And at that stage, the Eskom had put out a statement that they were specifically doing the refurbishment, and they had arranged to organize the maintenance of the coal fleet around this so that they weren't anticipating any load shedding. And I said, well, okay, and I want to make this absolutely clear, if there were no load shedding, and if there was no need to run the diesel peaking plant as much as we are running it, then the additional costs to the South African economy and the additional diesel costs to Eskom would not have materialized. It wouldn't be a problem. In other words, if we had enough energy and we had no load shedding and we didn't have to run the OCGTs, that would have been a good time to refurbish Koeberg if it made sense. So my whole take was, well, I've been looking at the coal fleet energy availability factors for a long time, and I thought, let me plug these numbers into my model and simulate what would happen if I said, instead of Koeberg being I don't know, let's call it a 90% availability factor or a 90% capacity factor. Now, I just need to qualify that. Through its life, Koeberg has averaged 73% capacity factor, not 90%. But I was generous and said, let's say that it could have been 90, but it's actually going to be 45 for 6 months. And so I put 45 into my simulated model, and I worked out that it would require about 2 billion rands worth of diesel And I think it was about 12 billion or 15 billion rands worth of cost of unserved electricity to our economy. And I used a very conservative figure of 20 rand a kilowatt hour. Those familiar with the concept of the cost of unserved electricity would know that at the low point, it's about 10 rand a kilowatt hour is one of the Eskom estimates. And at the high point, it's well over 100 rand a kilowatt hour. And I didn't really want to get into a big argument about that. So I chose a figure of 20 rand a kilowatt hour, which was heavily conservative and weighted towards Eskom's figure rather than to some other figures, like, for example, the figure used in the construction of the RP 2019 by the Department of Mineral Resources and Energy, where they used a figure of about 84 rand 50, if I remember correctly. So highly conservative. And I said, I put out a briefing note and I said, I think Koeberg's going to cost us the 20 billion, and as Peter's just shown us now, the 67 billion. But it's good. We could probably add, I don't know, about 20 or 30 billion onto that for the replacement of both sets of steam generators. So what I want to make very clear now is that what I'm going to tell you now is not modeling. What I'm telling you now is what actually has happened since Koeberg was taken off for the refurbishment. Remembering that the refurbishment didn't happen. As Peter said, the containment building wasn't ready. The safety elements weren't in place. But putting that aside, one is able now not to model what the cost is. One can actually simply take the data presented by Eskom on the data portal. And the numbers are quite frankly scary. So the additional cost of diesel burn directly attributable to the fact that half of Koeberg was not operating, rounded off to the nearest billion. I don't know if anyone in South Africa bothers rounding off to the nearest 100 million anymore. To the nearest billion, we have spent, in my estimation, so far this year, based on what's actually had to be the actual usage of the OCGTs has been, we've spent 5 billion more than we would have needed to spend had Koeberg not being refurbished. And so I also want to make very clear what we're talking about here is that not refurbishing Koeberg allows us to have Koeberg running at full speed, so to speak, apart from refueling, through to its end of life, at the very time when we've never needed electricity on our grid more than we need now. We absolutely unequivocally need the tail of Koeberg to wag and score some runs for us before we quietly close it down. And yet we've taken it offline at this time. So 5 billion worth of diesel directly attributable to the fact that Unit 2 at Koeberg was down. And I took the downtime I took it post 5 weeks of when the actual downtime happened. So I said, if there had just been a normal refueling, I'm not counting that time. So I don't talk about 8 months. I talk about probably 7.5 months, or sorry, 6.5 months when Koeberg hasn't been available. The cost to the economy based on the 20 rand cost of unserved electricity. Remind me, Peter, what was that figure? I get scared when I think it was 33 billion.
Yeah, 33. That's for the first of the 3 outages.
Yes, 33 billion up until when Unit 2 is back online, I think a couple of days ago. And I took off the short periods when it was running and calculated that, and I didn't count any diesel costs if they were coincident with load shedding costs. So I said either it's cost us extra diesel or it's cost us a stage of load shedding. 33 billion. So put those two together, we're talking 38 billion on top of Peter's 69 or whatever it was. We're well over 100 billion. But here's the scary bit. Eskom themselves have estimated that over the next 12 months, when I say estimated, if things are anything like they are at the moment, in fact, if they dramatically improve from where they are at the moment, we're in for permanent load shedding up to stage 3 for the next 12 months or the next 18 months. So we can safely say that doing the refurbishment of the steam generators at Unit 1 and then Unit 2 will take a year. There will be a year in this next 18 months period when we won't have either one or other of the Koeberg units up and running. And that year is translatable into 8,760 hours of stage 1 load shedding due to Koeberg, which rounds up, geez, I haven't got the number. I think it was 167 billion will be directly attributable to us trying to refurbish Koeberg at a time when the country is plunged into stage 6 load shedding, or stage 3, as Eskom themselves predict. So, yeah, that's it. We're talking, I don't know, 100 and something plus another 160. We're talking an amount of money here that is starting to inch towards Eskom's existing debt level. And just to put things in perspective, if Eskom ran through to its meant to close date in July 2024, it buys us time to put in sufficient wind, solar, and storage at a fraction of the cost of unserved electricity to the economy, and in fact about the same amount as what the refurbishment of of Koeberg will require. We could build that in inverted commas for nothing and replace the energy that we hope to get from Koeberg in the future. And just a last point on this, in 10 or so years' time, maybe 15 years, when Koeberg has to stop for its every 18 months refueling cycle, the question will arise, who's going to cover for Koeberg while it's refueling for 5 weeks? What's going to cover for it? And of course, the coal fleet will be gone by then. The gas fleet hopefully will never materialize. But what's going to cover for Koeberg for those 5 weeks? It's like saying the wind doesn't blow for 5 weeks and the sun doesn't shine for 5 weeks. And the answer is it'll be covered by renewables, wind, solar, and storage. And the question then should be, but if you can cover it for 5 weeks, why can't you cover it for 10? And if you can cover it for 10 weeks, why can't you cover it basically forever? And Koeberg in 15 years' time will be about as useful as a retired prop on a bench of sevens. Thank you.
Thanks very much, Clyde. And just to add those figures up, a couple of comments. Remember that the total we're talking about here is not the total to Eskom. We are also adding in the cost to the country in terms of the cost of unserved energy. Sorry, my computer froze up there for a second. Am I back?
Yes.
Thank you. So I was just saying the total we're giving here include not only the direct cost to Eskom, but the cost to the country as a whole. The other thing is we've used conservative figures. So Clyde is using 20 Rand a kilowatt hour of unserved energy. Other people use 100 Rand. So these figures could actually be a lot larger. In the same way I've said that might kind of double, we have seen worse than that happen in other projects. So the total that we come to with these conservative figures, about 345 billion, is the cost holistically to the country of doing this. And that's what Clyde is saying is edging close to the total debt of Eskom. So I think I'll stop there and invite any questions from anyone. Please just unmute yourself and go ahead. I think there are few enough people. We don't need to have hands up and so on.